this video, we're going to look at some parent functions. Parent functions are basic functions that if you learn them, you will be able to recognize that certain functions are in their family, and you'll be able to find some characteristics about these functions relatively easily. So let's look at the first one. Okay, the first one is a constant function. A constant function is simply a function in which the y value is always the same number. So in this picture that's shown, it looks like this y value is approximately, let's say it's approximately 1.25. So this function, we could write the equation as y equals 1.25. That essentially means that regardless of the x value, the y value is always 1.25. So if we were to make a table of values, if x was -7, y would be 1.25. If x was 0, y would be 1.25. If x was 19, y would be 1.25. Okay, it's a very simple function. This parent function, the domain, okay, the set of x values that are good for this function would be all real numbers. Okay, we could come up with any x value in that x column on the table. The range is going to simply be 1.25. So in interval notation, it looks something like that. Let's look at the next function. Okay, this is the identity function. And you could see in this little bubble on the graph here, let's highlight that. Okay, it's f of x equals x, which, remember, f of x is just a fancy way of saying y. This is just like saying y is equal to x. So if we were to make a table of values here, you know, let's come up with some random x values, say -17, we'll do 0 again, we'll do 119. The y values are the same as the x values. That's what that equation says. So that means y is -17. When x is 0, y is 0. When x is 119, y is 119. So our domain, in this case, you could look at the graph. The domain is going to be all real numbers, and I'm writing that in interval notation. And the range is going to be the same thing because y is equal to x. Now, there are other characteristics about these functions that we could look at. We could look at if the function is increasing or decreasing. We could look at symmetry. We could look at if the graph is even or odd. In this video, I'm just going to look at the different types of functions, look at tables of values, and look at the domain and range. So the third one, this is the absolute value function. And remember what the absolute value does. The absolute value, by definition, is the distance a value is from 0. And whenever we're looking at distance, that means that we're always looking at positive values. So let's just make a note of that. So let's make another table of values. And let's look at -27, 0, and 16. So now the y values are equal to the absolute value of x. So if x is -27, the y value is the absolute value of -27, which is simply +27. If the x value is 0, the absolute value of 0 is 0. And the absolute value of 16 is 16. So the output for this function, your y values, is always going to be positive. That doesn't mean that your inputs are always going to be positive. You can see that right here. Okay, we can have negative inputs, but the outputs are going to be positive. So our domain I just alluded to this, is going to be all real numbers. We can use all negative numbers. We could use all positive numbers. They all work as our inputs, but the outputs are always going to be positive or 0. So we're going to have 0 to positive infinity. We're going to be able to include 0, as you can see. We can take the absolute value of 0, which is 0, and we're going to put a parenthesis around positive infinity since we can never include it. Okay, the fourth function, a square root function. So we can see right here, this thing has an x and y intercept at the origin. That's the start of the function. So there are no values to the left of this function. Let's make a table of values quickly here. Let's do negative 17. Let's do 0. Let's do 9 and 10. So the y values are equal to the square root, oops, I wrote square root of 17. That should be the square root of x. Okay, so when x is negative 17, y would be equal to the square root of negative 17. Remember, we cannot find a square root of a negative number. It is undefined. So we actually do not have an output when x is negative 17. When x is 0, we could find the square root of 0. It's simply 0. When x is 9, we could find the square root of 9 to be 3. And when x is 10, we could find the square root of 10. Now, I can't really find this without a calculator. I do know it's greater than 3, and I know it's going to be less than 4, because if x was 16, the square root of 16 would be equal to 4. So I know it's between 3 and 4, and it's closer to 3. So let's say it's about 3.1-ish. So you can see here that our domain here cannot be all real numbers anymore, because when x is negative, we get something that's undefined for y. That is a problem. Remember, our domain is a set of all x values that work in the function, and negative values no longer work. So our domain is going to be from 0 to positive infinity. In our outputs from this function can also only be positive numbers or 0. So our domain and range are going to look the same in this case. Okay, we have 2 more functions to go. So we have the cubic function. So that's y equals x cubed. So now our y values are the cube of x, and let's pick, I'm going to keep these numbers a little bit smaller so I could actually deal with them. So when x is negative 2, y is going to be negative 8. When x is 0, we get 0. When x is 3, we get 27. So notice, negative values work for our inputs, and our outputs, we have negative values and positive values also. So our domain and range here are going to be all real numbers. And you can see this on the graph. Though this graph, this little clip of a graph, doesn't have arrows, there should be arrows there. They're sort of assumed because there are no endpoints. This function goes forever down to the left and forever up to the right. And our last parent function that we're going to look at in this class is a reciprocal function. That's y equals 1 over x. So this is often called a rational function or a reciprocal function. I'm going to make a table of values here. This one is a little more complicated than the other ones. So let's say we have x is negative 2, or -1 or 0 or 1 or 2. We'll stop there. So when x is -2, y is going to be 1 over -2, which is just equal to -1/2. When x is -1, y is going to be 1 over -1, which is just -1. When x is 0, we get y is 1 over 0. Remember, we cannot have a 0 in the denominator. That is undefined. When x is 1, y is 1 over 1. And when x is 2, y is 1 over 2. And you can see these y values are repeating but opposite signs. So now let's just take that table of values and look at the graph. Okay, we can find some of these that I plotted, that I calculated on the table. Here's -2, -1/2. Here's -1, -1. Now, 0 is undefined. Notice this graph does not cross the y-axis. This is what's called a vertical asymptote. Okay, the graph approaches this y-axis, gets really close to it, but never crosses it. And when we jump to the positive values, notice these are the two values that I found, 1, 1, and 2.5. And on the other side, this graph gets really close to the y-axis and again, doesn't cross it. And if I were to find other x values, if I were to use other x values that were closer to 0, so for instance, say I used x is a -1/4, and I were to plug that into the function, I would have 1 over -1/4, which if we do the arithmetic there, that ends up being -4. You could see that now that point is way down here. As I pick x values that are closer and closer to 0, my y values are going to get larger and larger. So now let's take a look at this domain. Our domain is going to be all real numbers except for 0. Remember, 0 gives us a 0 in the denominator, which is undefined. So the way we're going to write that is from -infinity to 0. Okay, but we're going to put a parenthesis around 0 because we can't include it. And then, so that domain describes the left portion of the graph there. And then from 0 to infinity describes the right portion of the graph. And we combine those with this union symbol. And basically that says all real numbers except 0. Complicated way of writing it. And then our range, we could see that this graph goes forever down and forever up. But again, it does not cross the x-axis. So our range is the same, looks the same, but we're describing the y values in this case. So I want you to be careful. I don't want you to think, oh, my domain and range are the same. Yeah, they look the same. But our domain is describing the x values from left to right. The range is describing the y values up and down. And that is the last parent function that we're going to look at in this class.